The automated aquaponic water management system with soil moisture monitoring project aims to create an automated environmental control system with Arduino and various sensors. The system tracks important conditions like temperature, humidity, soil moisture, and water level. It also controls devices such as pumps, fans, LEDs, and buzzers to keep a stable environment for plant and fish growth. By using structured programming and decisions based on sensor data, the project hopes to improve efficiency, limit human error, and provide steady climate control in aquaponic and vertical farming systems. The main goal is to show how automation can improve sustainability, reliability, and management in modern smart farming environments. I will present for the I/O list table. This table shows the I/O list for our smart irrigation system. It summarizes every sensor and actuator connected to the microcontroller, along with their functions and pin assignments. First, we have the TMP36 temperature sensor on pin A1, which acts as an input to measure the surrounding air or water temperature. Next is the HCSR04 ultrasonic sensor. The trigger pin is on digital pin 3 and the echo pin is on pin 4. This module helps us measure the distance to the water surface, allowing us to calculate the water level inside the tank. The soil moisture sensor connected to A0 also functions as an input and provides the soil moisture percentage ranging from 0 to 100%. Based on these inputs, the system controls several outputs. The water pump is connected to pin 8 and the cooling fan to pin 9, which turn on and off depending on the conditions. You also use 3 indicator LEDs, green on pin 10 to show normal status, yellow on pin 11 to indicate active pumping or cooling, and red on pin 12 to signal a critical condition like low water level. Finally, the piezo buzzer on pin 13 produces alarm tones between 1000 and 2500 Hz. Overall, this I/O list ensures every component is properly organized, making the system easy to troubleshoot, design, and program.
Hi, my name is Sarish. So now I'll be talking about the water tank level safety flowchart. So the system starts by checking the current water level. If the water level is not low, the program simply waits for a short delay and waits and checks again. But if the water level is still low, the system immediately turns on the red LED and activates the buzzer to signal a warning. It then prints a message saying the low water level and proceeds to shut down all system and function to prevent damage or malfunction. After shutting down, the process ends.
I am Patricia and I'll be explaining about the soil moisture control flowchart. So this flowchart shows how our system automates plant watering. It starts by reading soil moisture. If moisture is below 30%, the pump turns on for 5 seconds and off for 10 seconds while updating the LEDs and LCD. After each cycle, the system checks moisture again. If it's still low, the cycle repeats. If not, the pump stops and the system returns to normal mode. This ensures efficient and automatic watering without human intervention.
Next, I will briefly explain the flowchart for our temperature monitoring system used in the aquaponic setup. The process begins with the system starting up and reading the temperature from the sensor. The main decision point in this flowchart is whether the temperature exceeds the predefined high temperature threshold. If the temperature is high, the system immediately activates 3 components: the buzzer, the LED indicator, and the cooling fan. These actions help alert the user and regulate the system temperature. At the same time, the system prints a warning message stating that the temperature is critically high. After a short delay, the system continues monitoring. On the other hand, if the temperature is normal, the system turns off the buzzer, the LED, and the fan to save energy and keep the environment stable. It then performs a short delay to ensure smooth operation before repeating the process. Overall, this flowchart represents a simple but effective automatic temperature control system that ensures the aquaponics environment remains safe and stable for the plants and fish.
Assalamualaikum, my name is Nurul Shakila. Today I will present the Arduino program used in my automated aquaponic water management system with soil moisture monitoring. This code begins by importing the necessary libraries such as wire and liquid crystal to control the LCD display. Then, all important hardware pins are defined, including the temperature sensor, ultrasonic water level sensor, soil moisture sensor, pump, fan, LEDs, and buzzer. Next, the system sets several threshold values, such as the minimum soil moisture needed to activate the pump, the safe temperature range to activate the fan, and the minimum water level for system protection. Calibration value like tank height and sensor limit are also included to ensure accurate reading. The program uses timer and state variable to manage action like pump, cycle, blinking LED, and buzzer alert without blocking the program. Inside the loop, the system continuously read the temperature, humidity, soil moisture, and water level, then process the data to the control actuator. That concludes my part of the presentation. I will hand over to my teammate who will explain the next part. Thank you.
After all such are read, the loop continues with other functions like controlling the pump and fan, checking safety rules, controlling LEDs, and updating the LED display. These functions decides what to do based on their sensor values. Overall, this code is designed to constantly monitor the environment, react automatically, and keep the aquaponic system running safely and efficiently.
For this part of our project, I worked on the actuator control system, which includes both the water pump and the cooling fan. The goal here is to automate the plant environment so it can regulate itself without human intervention. First, for the pump control, the system reads the soil moisture value and checks whether it's below the minimum threshold. If the soil is too dry and there are no active alarms, the pump will automatically run in a cycle, 5 seconds on and 10 seconds off. This prevents overwatering and reduces stress on the pump. The logic uses the millis function to track timing instead of delays, so the system remains responsive. If the soil moisture becomes sufficient or an alarm is triggered, the pump immediately turns off for safety. Next, the fan control uses temperature readings. When the temperature rises above the maximum limit, the fan is turned on to cool down the environment. If the temperature drops below the minimum range, the fan turns off. And if the temperature returns to the optimal range, the fan is also switched off using a hysteresis method to avoid rapid on and off switching. Overall, this actuator system makes our smart farming project more efficient, autonomous, and safe by responding in real time to changing environmental conditions.
Okay, in this part, I handled the programming for the system. Okay, the code controls all the outputs such as LEDs, buzzer, the pump, the fan, and also updates the LCD display based on the sensor reading. So, the LED and buzzer control. This function manages the alert system. If the water level becomes critically low, the red LED will blink and the buzzer will beep to warn the user. The function also checks when the pump or fan is on. So when they start running, the system plays a short beep to notify the user. This helps to show that the system is responding to changes. Okay, for this part, we have safety condition check. So this part of the code protects the hardware. If the water level goes beyond the minimum safe value, the system immediately forces the pump to stop to avoid damage. It also prints a warning message. Once the water levels becomes normal again, the alarm is cleared automatically. So the second one is LCD display update. The system alternates between two types of LCD display every 3 seconds, and one shows the sensor data such as temperature, soil moisture, and water level, and the other shows system status like pump on, off, and fan on, off. This makes the LCD easier to read and give complete information without overcrowding the screen. And the last one is the display, the sensor and system status display. The display sensor data function prints real-time sensor readings on the LCD, and the display system status function shows the system mode, such as alarm low water, indicating when pump is on, cooling when fan is running, and last one is status optimal, when everything is normal. Thank you.
I will demonstrate our automated aquaponic system which monitor water level, temperature and soil moisture. The system uses 3 main sensors, which is water level, which measured by an ultrasonic sensor, the MP36 and soil moisture sensor. So for the first condition, if temperature exceeds 30 degrees Celsius, the fan will automatically turn on and to cool the system, and the yellow LED will light up as indicator that the environment is hot. At this time, the buzzer will make sound for 3 seconds. So right now temperature is 24 degrees Celsius. If we increase the temperature, the buzzer will make sound, and the fan will automatically run. And the LCD status right now is cooling. So let's move to the second condition. If the soil moisture is below 30%, it indicates that the soil is dry. So the pump will automatically water the plant in 5 seconds and will off for the 10 seconds to soil to absorb the water. And the yellow LED will also light up as indicator that the soil is dry. So right now soil is 63%. If we decrease the soil moisture, the buzzer will make sound, the yellow LED will light up, the water will pump for 5 seconds, and the LCD status right now show irrigating. So for the 10-second cooling down, soil will absorb the water. So the status will show optimal, and after 10 seconds, the pump will turn on back. Okay. For the last condition, if the water temp measured by ultrasonic sensor is low, below 5%, the red LED will light up and the buzzer will sound continuously to let user that the water level in tank is low. At this time, pump will automatically shut off to avoid server damage and the LCD will show the status. So right now water is 73%. If we decrease the water level, the pump will off and the LCD status will show low water and the buzzer will sound continue. In case multiple critical conditions occur simultaneously, such as soil dry, high temperature and low water, the pump will automatically shut off to prevent the damage, while the fan will continue running to cool the system to prevent overheating. So let's decrease the soil moisture, increase the temperature, and decrease the low water level. Okay, the pump will automatically shut off and the LCD status right now is low water. That's all from us. Thank you.
Technical highlights from this project is we have integrated multiple sensors such as temperature, TMP36, ultrasonic water level, soil moisture, and we have also controlled actuators including pump, fan, buzzer, and indicator LEDs. The educational impact that we got from this project is we have improved practical problem solving skills through circuit design and debugging, gained hands-on experience in automation, sustainable farming technology, and system interfacing, enhanced readiness for future engineering projects involving intelligent control systems. So that's all from our group. Thank you.